Hey guys, welcome to another lesson here. This is 2019 Kaplan Math book, and we are on, let's see, multiplication and division. This is fraction, multiplication and division, which is under lesson 4, fraction operations. So yeah, here we go. We're going to be working on the practice 4.2. Okay, so as I normally do, I'm showing you guys this page here because this is basically the explanation of what it is that we're going to need to do. But I'm not going to go through all this because I'll be explaining it as we actually do the problem. So I'm just going to take this bad boy, put it down here. A lot of this material actually I basically redid it because it's been a while since I've done all this math, and I've kind of had to refresh a bit myself and then go ahead and make the class. It is late at night too. It's 1 o'clock right now, so if I'm a bit sluggish, forgive me, but I'll try and get this information across to you. Okay, so we have basically, let me try and make this a little larger. That's not what I wanted to do. Cancel. Trying to scroll down. There we go. Okay, so reduce, solve. Okay, remember last time I was saying make sure you read the instructions explicitly because there's 3 things you need to do here. First is solve, second is reduce answers to lowest terms, and simplify improper fractions as mixed numbers. So let's see, simplify improper fractions as mixed numbers. Okay. So let's start on this multiplication of, I'm not going to do all of these, I'm going to do about 4 of them. Probably go this way just so we get a variety instead of just going in order like this. So let's see, 2 over 3 times 1 over 4, so 2 over 3 times 1 . Okay, so unlike what was it, addition and subtraction, the denominators do not need to be the same in multiplication and division. So basically just write down the problem and voila. There is something called canceling though for multiplication and division, which is, you see the problem here. So if we were to do this just as is, we'd have to reduce it later on, but canceling saves that step. If you can cancel, like for example, 2 goes into itself and 4. Okay, it goes into itself once. So we put a 1 here, it goes into 4 twice. Okay, so that was basically reducing, which is called canceling before you actually complete the problem. So 1 over 1, that's 1 times 1, and then 2 times 3, it's 6. Okay, had we not canceled, I'll show you what it would have been. It would have been 1 times 2 is 2, and then 4 times 3 is 12. Okay, then that's not reduced, we still have to reduce it. And since this is a bit of a bigger number, if this could be a little more challenging, because say this was 3 and this was 38, then you'd have to see how many times 3 goes into 38, etc., etc. Or you just have to see the biggest number that goes into both of them, etc. So this kind of does it dealing with smaller numbers when you cancel, so it does make it a bit easier for you. Okay, so your answer for that one is 1 over 6. So second one is 1 and 5 over 6 times a half. So 1, 5 over 6 times 1/2, or 1 over 2. Remember, anytime the number on top is half the number on the bottom, we know that it equals half. Okay, so with mixed numbers, you have to resolve them into improper fraction. Remember, improper fraction is when the number on top, say it's 5, 6 right now, 5 over 6, if this was a 15, and there was no 1 here, that would be an improper fraction. Otherwise, basically what I'm about to show you. So, make it an improper fraction. We go 6 times 1 is 6, okay? Plus 5 is 11. So cross out this 1 here. We'll cross this out as well. Then we'll make this 11. Okay, so now we check to see if this can be canceled at all, and no, it can't, because 2 does not go into 11, 1 does not go into 6. So 1 times 11 is 11, and 2 times 6 is 12. And can this be reduced any further? No, it cannot, because there's no number that will go into both of these here. Evenly, that is. So number 2 is, what was that? 11 over 12, 11 twelfths. Okay, so let's skip over here to number 7, so we have a little bit of a variety of multiplication. That was 2 1/3 and 3 2/5. Okay, so again with multiplication you must resolve the improper fractions, which is this here and this as well, into mixed numbers into improper fractions like we did here, 11 over 6. So 2 times 3 is 6, plus 1 is 7. Let's cross that out, make it a 7. And 3 times 5 is 15, plus the 2 is 17. So we'll cross out the 2, make 17 there. And let's see if we can cancel anything here. 3 does not go into 17. There's no number that goes into both of them either. Same with 5 and 7. So we shall multiply. Okay. So 7 times 17 is 119. 3 times 5 is 15. Now you could, set this up as a division problem like this. 15 into 119, but really you really just have to see how many times 5 goes into 5 times how many times 5 goes into 119, or at least get close. So 5 times, for example, 7. Oh, sorry, not 5. I meant 15 when I said 5. So 15 times 7 is 105. Okay, so I have 105. So we know it goes in there 7 times. And, 119 minus 105 is 14. Okay, so we know that's the remainder. So we have 119 over 15. Goes there 7 times, and there's 14 left over. So 14 over 15. Okay. Now we still need to reduce this number here. Actually, no, we don't, because that is, let me check something real quick. Yeah, that is the lowest it'll go. So that's your answer. 7. This can't be reduced because there's no number that goes into both of them evenly. So 7 and 14 over 15 is your answer for number 7. Okay, now number 8 is 15 times 2 3/4. Let me erase some of this. So 15 times 2 3/4. Okay, so we need to make this 15 into a fraction to be able to do this problem correctly. So putting a 1 under it does not change its value. Anything with a 1 under it remains this number. So this was a whole number before we added this, and the whole number was 15. Anything over 1 is still the value of the top number as a whole number. So we need to change this to an improper fraction from a mixed number. So 2 times 4 is 8, plus 3 is 11. So let's cross this bad boy out, make this an 11. Cross this 2 out, so we're no longer using that. Let's try and cancel. There's no number that goes into 4 and 15 evenly. Same with 1 and 11. And 1 does not count, as in 1 can obviously go into 4 and 15 evenly, but it doesn't count in canceling. Okay, so 11 times 15. I know you all know that in your head. That number is 165. 4 times 1 is 4. Okay, so we have to see how many times 4 goes into 165. So 4. Anytime the number is larger like that, just divide it, whether you use the calculator if you're allowed to, or whether you have to set up the division problem, or like we did last time, had to see 15, multiply 15, see which number brings it as close to 119 without it going over. Okay, so those are different methods you have to use. So 4 goes into 16 4 times. 4 times 4 is 16. Yes, we know that. 16 minus 16 is 0. Does 4 go into 0? It does not. So bring down the 5. Beautiful 5. Does 4 go into 5? Well, yes, it does. 1 time. So there we go. Now 1 times 4 is 4. 5 minus 4 is 1. And we are at the end here. So 1 is your remainder. Okay? So remainder 1. Yes, it is. I don't lie. Okay, so this here is equals 41 because 4 goes into 165 41 times, and there is one remainder, okay, which would be 1 over the denominator. So 41 and 1/4. That would be the answer for number 8. Okay, now we're going to do, see, 4 of these, 11 and 12, and probably, well, I'll decide as I go. Let me erase this. Okay, so I'm gonna skip this because this is a very basic one. I'll do this one here since we have to do something unique with that. So 12 and divided by 1/4. So 12. So anytime you have a whole number, you have to change it to a fraction, okay? So remember, putting a 1 does not change the value of that 12. Let me make this a little nicer. I know I have it in me. Okay, so now with division, you actually have to invert this number here. So you would flip it around, okay? Basically like this. It's division, but now you actually have to flip this number around. So we'll change it, flip it around. Okay, and when you flip it around, it becomes a multiplication problem. This is true for all of these division fractions that we're going to be doing. Okay, so 4 over 1. This is going to be an easy one. Okay, so 12 times 4 is 48. 1 times 1 is 1. So remember I said anytime there's a 1 underneath, the value is this number here. Okay, because it takes one piece to make a whole unit, and we have 48 pieces. So this is your answer, 48. Simple as that. So that would be your answer for number 12. Let's see. We'll go ahead, since we just did one of these ones that we had turned into fraction, we'll do this one over here. Okay, so we'll do number 14, which is 3 and 3/4. And this one divided by 1 and 2/3. Since we did skip over this one, just to let you know, you do the same thing here. You'd put a 1 under it to make it into fraction. Then you would, like we did in multiplication, we would change this number here into an improper fraction, okay, which is basically the top number larger than the bottom number. So basically what we're going to do here. So we need to resolve this into a mixed number. Sorry, it is a mixed number. It needs to be resolved into an improper fraction. So 3 times 4 is 12, plus another 3 is 15. So I'm going to put 15 here and cross out the 3 since it's no longer that. And It's no longer this as well. Same here, 3 times 1 is 3, plus the 2 is 5. Cross out this, make it a 5, and cross out the 1. And remember what we do next. We have to invert this over here. So I'll show you. Same thing we did last time. Change it to multiplication since we're inverting it. Now the 3 will be on top of the 5. That happens every time. Okay. So let's see if some of this can be canceled first. Is there a number that goes into 3 and 4? There is not, other than 1, but 1 doesn't count. This, yes, 5 goes into itself once, and 5 also goes into 15 3 times. Okay, so right there we just did the whole simplifying it. So 3 times 3 is 9. Okay, and 1 times 4 is 4. Okay, so now let's do this. How many we have to make this? Like it says, simplify improper fractions as mixed numbers. So this is an improper fraction. So we have to now make it a mixed number. So 4 goes into 9 2 times. So we know that 2 times 4 is 8. So there's 1 left over. So 2 and 1 remaining. So we put the 1 over the denominator right there. That's always how you solve a mixed number. Or sorry, an improper fraction. Keep getting those mixed up. Like I said, it is 1 o'clock at night. What happened was, this is a pretty new channel, and as of right now, I have five subscribers. I was laying down in my bed, I couldn't fall asleep. Then I got a subscriber. Somebody just subscribed, so I was like, oh, that gave me the inspiration to get up and put this video out. So yes. Okay. Let's see. We are farmers. That's a commercial, by the way. We're not really farmers. We'll do 15, then 16. Okay. Make it easy on me. 9, 1 over divided by 1/3. Okay. So remember, we have to turn this into a fraction. Okay, now we have to invert this. So basically set up again. What I generally do, guys, is like this to me is obvious. So when I actually look at the problem, instead of writing it down like this first, I simply just, since I know that I have to invert that, I just put 3 on top and 1 underneath and put the multiplication sign like that instead of doing that whole step there, which is kind of dumb. Okay, so 3 times 9 is 27. Sorry for that accent, not sure where that came from. 1 times 1 is 1, so we need to change this to a proper fraction. So we know that anything over 1 is this number here, so 27. Okay, that is the answer for number 15. Let me verify. Yeah, okay. So let's do 16 now. Okay, number 16 is 26. Beautiful 26 and 2/3. See, this is where I would look at this and just be like, see, 16, I'd be like, 3 times 3 is 9 plus 1 is 10. So it's 10 over 3, okay? And then basically I'm looking at number 16 here, guys. So it's 10 over 3, and I know I need to invert it, so I just go ahead and put 3 over 10. Okay, so I'm going to do that now. 3 over 10. Hope you guys got that. I will show you one more time. Follow the cursor here. I'm on number 16 in case you can't see the cursor. So I did, since I know we're supposed to invert this here, I just resolved it here. 3 times 3 is 9, plus 1 is 10, so which makes it 10 over 3. Then we invert it to 3 over 10 and change it to multiplication. Now we need to change this to a proper fraction, improper fraction. 3 times 26, 75, 76, and 7, 78. 70, okay, so it's, yeah, 3 times 26, 78, plus the 2 is 80. Okay, so let's cross this out. We shall make it 80 because we can, and we should, so we shall. Okay, 3 times 80 is, well, I go 3 times 8 is 24, so, yeah, 24. Plus there's a 0 there, so I will add the 0 as well. It's an easy way to do it. Then 3 times 10 is 30. You know what, guys? Sorry. Let's cancel first. So we know that otherwise we would have to do 30 goes into 240, and that would be a little bit of a pain. So 3 goes into, we know that these are both 3's, so they both go into each other. Okay, so we make that a 1. The 3 goes into 3 one time. 10 goes into 80 8 times. So change this to a 8. Okay, then this to a 1. So now we have 1 times 8 and 1 times 1. That made it so much easier. So again, 8 over 1 always equals 8. So that is your answer for number 16. Beautiful. Okay, let's get on to the story problems over here. The story problems, they do take practice and doing them, because sometimes it's a bit hard to tell what you're supposed to do. Should you multiply or should you divide, but the more you do them, it gets easier. So let's see. A city is considering raising taxes to build a football stadium. A survey of registered voters yielded the following results. Okay, so, if 400 people were surveyed, how many support the tax hike? So this is people for the tax hike. It's 3/16, okay? So we need to find out, since we know that there's 400 people that were surveyed, and this is kind of the amount of people. This is the total amount of people, so 16 represents 400, and 3 represents the amount of people, amount of the 400 that voted for the tax hike, or that liked the tax hike. So let's see, so 400, we need to multiply that. 400 times 3 over 16. And remember, we need to make 400 into a fraction. Okay, just add a 1 so it keeps the same value of 400. Can this be reduced? This cannot. This can, because 16 goes into 400 25 times. Okay. Anytime that it's this actual number that goes into there, the larger number, this would become a 1. Okay. If this number goes in there evenly. If for example, we had to use another number, such as this doesn't necessarily go into there, but another number does, say 8 went into that, okay? So then, since 8 is half of 16, we know that this would have a value of 2. 16 would now have, would be a 2, and then that number would be, you know, half of what that is, double of what it is right now. But 16 does go into evenly. So that simplifies things again for us. 3 times 25 is 75, staying alive. And remember, 1 times 1 is 1. Anything with a 1 under it is the number on top. Okay? So 75 is your answer. Let's see if that's an option. Yes, it is. B is your answer. Okay. The next question is, a tailor has 20 yards of shirt fabric. How many shirts can she complete if each shirt requires 2 3/4 yards of fabric? So, we have 20 yards, okay? This one's a division problem. So we have 20 yards, and what was it, 2 3/4? 3/4. Let's put the 2 here. Okay, it's a little squishy here, so we make this into a fraction. Okay, this is division. Okay, because basically, since it takes this much to make one item, okay, or what was it exactly? A shirt. We need to see how many of these can fit into 20, and that'll give us the number that we need. That'll give us how many, yeah, basically the number that we're looking for to see how many of these fit into 20. So remember, with division and multiplication, we have to change this to proper improper fractions. So 2 times 4 is 8, plus 3, 9, 10, 11. Cross out the 3 since it's no longer that. We cross out the 2 since we used it to make the 11. Okay, and then remember, we have to invert this number. So that will be 7 over 11. Okay, so we have to do 7 times 20. Well, we know 5 times 20 is 100, so you do the math. 2 more 20s would be 40. Okay, which would be 140. So let's do this 140 here. And 1 times 11 is 11. Now we have to divide this. 11 goes into 140. Well, 140 divided by 11 is, it goes in there 12 times, because, yeah, 12. Let's see, 12 times 11 is 132. So 140 minus 132 is 8. Okay, then we take the denominator and we keep it. Then we see if we got that right. And we did not get it right for some strange reason. Okay, let's do that problem again. Let me try and figure out what I did wrong here. 2 times 4 is, did it have a 2 there? Yeah, it did. 2 times 4 is 8 plus 3 is 11. Oh, look, I put the 7 here instead of a 4. I'm not sure why I did that. Let me see. Okay, so I'll just travel back to a place where I messed up. So when we inverted this here, 11 and 4, I put a 7 up here when I should have put the 4. Silly me. Okay, so 4 times 20 is 80. Okay. Over 11. So 11 goes into 80 how many times, guys? Let's see. 80 divided by 11 is 7 times. Okay. 7 times 11, you know, anything times 11 is be the same number twice, so 77, up till a certain point, that is. Okay, so the difference here is 3 numbers. 80 minus 77 is 3. Oh, why am I putting 77 there? Sorry. So it's 7 and 3 over the denominator, which is 11. Okay. Now, so see how we have 7 and 3/11ths? The thing here is there is no 7 3/11ths. There's a 7, but remember it says how many can we make? How many shirts can she complete if each shirt requires this much? So your answer is 7 because that's how many she can actually complete. And there would be this fabric left over, which is not enough to complete the shirt. Okay. If it was 11 over 11, then this number would have been 8, and we could have completed 8. But anything lower than 11 here will not cut it for a whole another shirt. All right. Okay, so an insurance agent estimates that, this 21 by the way, estimates that it takes, that it takes two-thirds of an hour to process a customer's claim. If the agent spends 22 hours per week processing claims, about how many claims does he process in a week? Well, that's a darn good question. Thanks for asking. Okay, so here we need to divide, okay? Because we have that 22 number. And we're trying, so we have the 22, which is total hours she spends, and it takes 2/3 of an hour to process a single customer's claim, okay? So what we need to do is figure out how many of these can fit into this here. So we need to make this into a fraction. Okay, now that we've made this into a fraction, we need to invert this. So let me scratch this out and just put 3 over 2. Okay, and now we change this to multiplication. Okay, let's cancel. Does 2 go into 22? Yes, it does, 11 times. So, yeah, 1 there and 11 here. So 3 times 11, remember anything times 11 is itself twice, 33, and 1 times 1 is 1. So remember, anything over 1 is the top number, so it's equal to 33. So it would be B. Okay, let's clear this. And for our last problem of the night, okay, so a fluorescent lighting panel is 12 and 5/8 of an inch wide. If 3 of the panels are installed as shown below, what will be the width in inches of the combined panels? So we have a fluorescent light panel which is 12 inches and 5/8 of an inch. Okay, so multiplied by 3, because we need, if 3 of the panels are installed as shown, what will be the width in inches of the combined panels? So we have 3 panels of this amount here. Okay, so we need to make 3 into a fraction. So there we go. And we need to make this mixed number, turn the mixed number into an improper fraction. So we go 8 times 12, okay, equals 96. Plus 5 is 101. So let's cross this out. Let's cross this out. 101. Can anything be simplified? There's no number that goes into both of these, unfortunately, because this is going to be a big number. So 3 times 101 is 303. 8 times 1 is 8. Okay, so now we have to see how many times 8 goes into 303. So 303 divided by 8, okay, it goes in there 37 times. So 37, but there is some remaining. So let's see, 37 times 8 equals 296. So we need to see 303 minus 296. Well, you can just kind of count this one up. Would be 4, 5, 6, 7. So the difference is 7. Put 7 there and 8 here because that's the denominator. Then can these be simplified or reduced? No, they can't, because there's no number that will go into both of them evenly besides 1, which doesn't count. So 37 and 7/8 is letter C, and that is your answer. Anyways, guys, thank you. Appreciate you staying up this late with me. Well, it may not be this late for you when you're watching this, but if you did appreciate this help, please go ahead, subscribe and like, share it with a friend if you know they're studying for the GED or just need to brush up on what we talked about. And thank you very much.